Hi there, this is Jacob Nash, and this is a review of Module 20. Listen! So this is about hearing. Okay, audition. What is audition? Well, it's not the same thing as what you might think, which is like something you have to do to try out for something. When we talk about that, we're talking about the act of hearing. That's just what it is. Oh, sorry. Okay, frequency. This is measured in hertz, and this is the number of complete wavelengths that pass in a given time. So waves per second. It's not the same thing as wavelength, but as you can see, high frequency, low frequency. Pitch depends on frequency. Now remember, we already talked about amplitude. How high it is says how loud it is, but how fast or how far apart or close they are determines pitch. So those are pictures of my grandma. So she hates high pitches. So what would my grandma do in both of those situations? Let's see, the one to the left. She would do that because she would be like, haha, turn that off. Because she hates high pitches. But then over there, she wouldn't really care because it's just low pitch. Okay, parts of the ear. So there's 3 sections of the ear: outer ear, middle ear, inner ear. The outer ear has the pinna, canal, and eardrum. The pinna is basically just the thing that you commonly think of when you think of the ear, the thing that you can touch that's your ear. The canal is just the part, like the hole, kind of like a tunnel, and then the eardrum's back there. You actually can touch your eardrum, like if you've stuck something in your ear, but that's not good to do. And then the middle ear, this has the ossicle bones, and there are 3: hammer, anvil, and stirrup. Those are what we commonly see the names as, but just keep in mind that they are called malleus, incus, and stapes. But you probably don't need to know that, but they're called hammer, anvil, and stirrup. Then what connects the middle ear to the inner ear is the oval window, and the thing that's in the inner ear is the cochlea. And then as you can see, the auditory nerve, what do we think of? What do you think that goes to? That goes to the temporal lobe, because remember, that's what part of the brain we use for hearing. Okay, what if your ear canal collapsed? That wouldn't be good, because then you wouldn't be able to balance. It helps us balance. So pretend like your ears collapsed. You might do that like, so you'd have to be careful. Hearing losses. So there's 2 types of hearing losses you need to know. Sensorineural hearing loss. I might be saying that wrong. Sensorineural, but it's a written test. That, just so you know, you don't have to know how to pronounce it. You just have to know what it looks like. But it's caused by damage to the cochlea's receptor cells. It's also called nerve damage. But conduction hearing loss, this is damage to the mechanical system that conducts sound waves to the cochlea. What mechanical system is that? I'll talk about that in a minute. Okay, cochlear implant. This is something that someone can get where they literally make something. You see that thing? They make that connect to your cochlea, and it can convert sounds into electrical signals. So if you have some kind of problem, it can help. So what really is loudness? Well, loudness is determined by the number of hair cells activated. The hair cells are cilia. And so if it's like this, okay, not that many were activated, but then whoa, if there was a lot, if it was really loud. All right, there's 2 theories about pitch. There's the place theory. It says that pitch is determined by the place where the cochlea is stimulated. The frequency theory says the frequency of nerve impulses enables us to sense pitch. All right, frequency distribution. This is just telling you that basically what is safe and what's not. So the intensity, we can measure that in decibels, dB. So look, apparently, these things can result in hearing loss. Rock band, loud thunder, jet plane, subway train. So that's something kind of interesting to think about. I've been to concerts before, so that's not so good because you never know if you can have hearing loss from that. But obviously the closer you are, the worse that it is. Okay, so here's some questions. All right, what is the coiled tube in the inner ear that contains auditory receptors? Well, I didn't really explain this, so that's okay if you didn't know, but that's the cochlea. It is a coiled tube, and it is in the inner ear. So maybe you would have known by that, because that's the only thing I said that was in the inner ear. What is the purpose of the ossicle bones? Remember hammer, anvil, stirrup? They pick up on vibrations and send them to the cochlea. I guess I didn't really explain that, so I apologize for that. But that's the reason why it's good to have these questions. And like I said, I didn't make them. I should have probably read what they said before I made the slideshow. That's what they do. Well, 10 is pretty much saying the same thing, but anyways, list a sequence of anatomical structures that sound passes through. Here's the order. Goes from inner to outer. Pinna, ear canal, eardrum. Hammer, anvil, stirrup, oval window, cochlea. Because remember, the oval window connects the ossicle bones to the inner ear, the middle ear to the inner ear. What does frequency determine? It determines pitch. What does the semicircular canals do? Didn't talk about this, but here's what they do. They help you keep your balance. Well, no, I did talk about that. Sorry. I just said ear canals, so I didn't call them semicircular. But remember, I told you if they collapsed, then you wouldn't be able to balance. All right. Explain frequency distribution. Frequency distribution of sound displays intensity and what is safe for the ear and what is not. About. Well, I think it was supposed to say above 85 decibels is considered unsafe. The cochlea is part of what system? It's called the auditory system. The middle ear consists of the hammer, anvil, and stirrup. What type of hearing loss is due to ossicles that transmit sound waves to the cochlea? Remember, that's what I was telling you. That's conduction hearing loss. That's the mechanical system. And I kind of already said that they transmit vibrations by sound waves to the eardrum to the inner ear. Okay, I didn't have a final slide. Thank you for watching.